Okay, so I'll just quickly conduct our test. So what I'm doing is just doing a little bit of water into this 250 milliliter beaker, maybe about 25 milliliters, and then we'll do 5 drops, 5 of universal indicator. You can see that it turns the water blue, which makes sense, or a greenish blue, because this water is neutral. And then I'm gonna blow bubbles, and we'll see if the color changes. Oh, check out that beautiful yellow. So the air that I breathe out is clearly acidic. Now, let me get another straw. You can dry that straw if you want, but I'm just gonna, so I can do it quickly. I'm just gonna take this nice blue cobalt coir strip, and I'm also gonna take another deep breath and just blow on it, see what happens. And you can clearly see that on this side it's pink, on this side where I had it covered with my finger, it's blue. So water vapor is coming out of my lungs. Now that's not necessarily a great test because we have water in our saliva, so maybe I'm spitting out some water. But if we were to do this over and over again and somehow avoid the saliva coming out, we would see, and other scientists have shown, that there is water vapor coming, that there is water vapor in the air from our lungs that we exhale. So super interesting. As far as we know, given the 2 tests that we have run, the gas of a flame is the same gas as the gas we exhale. This is a fascinating result. Of course, it's not proof. Just because you have 2 properties in common doesn't mean every other property is in common, but it's, it's in the right direction. It's suggestive that they might be similar or are the same gases. Interestingly, the mephitic gases are referred to in the launch, which is the gas that comes out of yeast in the process of making beer. Joseph Priestley analyzed this, and he said, or he noticed, that they have the same properties of the gas of exhalation and the gas of a flame. So now we have these 3 gases from 3 different sources that may be the same. And one other interesting thing here, you can't ignore the fact that both, and I touched on this earlier, that both flames and humans are warm. So maybe there's some sort of combustion type of process that goes on with the air we take in that heats us up and produces this gas that we exhale. So let's go ahead and make the bold claim that the gas we exhale is the same as the gas of fire, and Priestley would say is the same as gas produced by yeast in the process of beer making, and he called this gas mephitic air. But a problem arises if we make this claim. It has to do with the theory of phlogiston, which was, as you know, the going theory, the accepted theory in the 1700s of fire and what fire is. So you remember the theory says that fire is nothing more than the release of phlogiston inside of materials which have phlogiston in them. And when you have a flame, it produces phlogisticated air, but that air will become saturated with phlogiston after a period of time, and that's why a flame extinguishes, because there's no more space for more phlogiston to be released, and so the candle extinguishes. But the problem is, if we are also producing phlogiston or phlogisticated air when we breathe, if that's the same gas, the gas we produce is the same as the gas of a flame, then what we're producing is phlogiston. And we've been around, and land animals have been around for millions of years. How come the Earth isn't saturated with phlogiston? How come our atmosphere isn't saturated with phlogiston? Well, he made an amazing, interesting discovery, and that's plants sort of reverse the process or the production of phlogiston, because he did this experiment. If you have an ant or a mouse inside of a closed container with a flame, that mouse or ant will suffocate in a short period of time because the flame and the mouse are producing phlogiston. The air becomes saturated with this phlogisticated air, and the mouse can no longer release its phlogiston, and evidently if it can't exhale, it dies. But he noticed if you put a plant in that same container, the mouse or the ant will live a little bit longer. It's as if the plant is eating up the phlogiston and allowing more phlogiston to be produced, and thereby allowing the mice or the ant to live longer. So he did these experiments. But it was suspected that maybe the plant is not eating up the phlogiston, but is producing some other type of air. And one name that was being used at this time, it was all theoretical, was vital air. So it could be another type of air that could be discovered, vital air. And so this is where we'll start in the next chapter, is we'll see if we can make this vital air and analyze its properties.